Hello everyone. So today I'm gonna do a live stream review from S25. Now it's 5:30 p.m. and I'm just gonna get started. Okay, so I forgot to mirror my videos here. Yeah, this should be normal. So the recording it has started. It's gonna be Math 125. The Midterm 2 review. So today I'm gonna go over some like the other problems that I put on the outline, like reviews. And we will cover the work, integration by part, and trig integrals, trigs, partial fractions, and approximation and improper integrals. So let's start with our very first question. It is the portion of the graph y could arctangent of x from x to a 0 to 1, rotating about the y-axis to form a container. So, and this is a word, and I think it's like there's like a function because of y because arctangent of x, so it's inverse tangent. So we have the y equals to arctangent of x from x equal to 0 to x equal to 1. So I just want to know, so see my screen, right? Thank you.
Yes, we can see your screen, Andy.
Okay, so it has from like 0 to 1. So we just sketch the region, and now we have is from it looks like perhaps it's just this from like 0 to 1, and this is arctangent, and is rotating about the y-axis. So when you see the y-axis rotation, then we're gonna use the shell method. So it's a region because of y-axis, and it's like the volume it is b to the a in 2 pi x and then f of x dx. So it's like the area rotating about like the oh wait, what happened? Rotating about like the y-axis. So now we just try to just set the volume equation first. So we have the x value is in a bound. So it's like the I think we just need to find the volume and just multiply by like the density here. So the volume it is from 1 to 0, and then we have is going to be 2 pi. So 2 pi x. Is this going to be arctangent of x? Dx. So we have this volume equation here. Okay, make sure my video is in recording, right? Okay. And then we just find, because this is like the volume that we all need to for like slice it. And now we just try to, now we are giving like the density and the gravity here. So we're pumping all the work and volume. So like, I think the work is, I interpret as like all the volume and the density and like all the mass just all together. So we just put them as all the work you need for Plus 1, 0 unchanged, but 2 pi is still in there. I just need time like the density and yeah. So the recording will be posted by tonight, like 9 p.m. 9:30, no later than 10 p.m. tonight on my YouTube channel, and I will drop the link once the recording it is available tonight. And I will just scan on my note and put on Discord because I have an outline, but it's like 45 pages. I don't want to send like a mega PDF there, so. And what I have is like the density is like 250. So you just try to do is like density and the times it's like the volume is like, yeah. And just try to integrate, then that's just the work. Is there any questions? Because I just try to work through like many questions as possible because I have like 18 questions planned, so there are about 18 different questions that that I went over today.
I have a quick question. What does the 9.8 times 250 represent? Is that the force?
Yes, the force. So it's a 4 times like distance, and I just and if you have any questions, please just put on the chat, and I would just and I will answer like after like the main review like the part. So like the first part,
Also, Andy, could you like take the paper and pull it up a bit because we cannot see some of the lines? Okay.
Maybe I would
you.
just adjust my camera. And also if I do anything wrong, please let me know, and I will change by the end of the recording because I try to get everything in this here. So, and the next it is another word problem, and this number and the question 2 from my outline. So it's from like so it's from like lifting cable. And it's from like initial for autumn 2016 exam. So it's like, but I changed the number. So, and so number 2, it is 20 feet long chain weight 60 pounds. So column LC, and this is like so you have 20 feet and is 60 pounds, and find the work required to lift the lower end of the chain to something that is lower mid upper bound. So we just sketch just like, so here is like the cable, and here's this something here, and the 20 feet is the height. Wait, I don't want people to leave. I'm doing something wrong.
Also, you might want to like pull the paper up again because it's going off screen.
Now you can see it, right?
Yeah, I can see it.
I am not sure whether this is the people might leaving, because if I do anything bad, please let me know, because I try not to mess it up. So now we have this, and what you can find is like the what you can find it is like the height here is like, this is the thickness, and so what you can find is like the height, and the height is like 10 meters. Wait, 10 to 20 means this is like the delta y. And so what you try to make is like this way. So here's the solving. So you try to make it like, so the bottom is just there like evenly in the two-sided. And so for like the distance, it will be, and for the weight, it's gonna be 3 pounds and per feet. So this is the work. I think this kind of like represent like the mass here. And so if like the two sides are like if the ones, so one side is like a 20 feet. So now if you turn to this case, so each the height will be 20 to 10 feet. So 10 is like the height. So it's like if you try to compute like work done, then you set the upper bound to 10, not 20. Because when we make like this, so two sides are even. And now what you try to do is here's like the because there are two, one is right and the one on the left. So it's like here's like the mass, and then you just need to find it's like, so lower bound is 0, upper bound is a 10, and they have more like a masses here. 3 and the height for like a distance, because you're pulling like the chain so vertically. So you just like the distance going to be 10 minutes y. So that's just how many vertical distance that it moved on the cable. So 10 minus y will be like the distance that it moved. And for dy, and for dy here, because like there's no gravity here, so that's just like the mass and like, so like a force and a distance, here's our integral. I mean just and then like 3 and 30 minus 3y dy, let me just deduce like, and minus 2 over 3y to the squared, and then 3, so it's going to be 210 minus 150, and then plus 9, so going to be 27 over 2. So it's going to be 100. So going to be 147 over 2. Because they're in feet and pounds. Make sure you have make sure you have unit is right. So work done. So the work done total going to be 147 over 2 is like feet and then pounds. So I bet it's like this may be kind of a confusing, so I've just re-explained the question again. So we have electric cable is a 20 feet long, and now we try just to make them, to pull them upward to make the lower, and to make them shape like a U shape. And when they're making a U shape, so they're both sides that have the same height, they're 10 feet long. And then when we calculate one side when they're mass, we multiply it by 2 because they're two sides. And each and for distance of 10 feet, so like the vertical distance is the 10 minus y, and we just multiply it 3, and then we just yep, we just do the whole work. And if I make any mistake, please let me know, and I may change it after the video.
Could we go over one more time why when we took the integral 30 ended up becoming 210?
Okay, I think for for 30 here. So the antiderivative of 30 becomes 30x and then minus 10. Oh, wait. Sorry for catching me, because like my lower bound should be a 0, not 3. I'm so apologetic for the mistake because why am it? Thank you for catching that. Oh. So the total is 450.
Wait, Andy,
What?
hang on a minute. So if we just take the integral of that in general, why am I not seeing 30y minus 3 over 2y squared?
Here. Here 3 over 2y squared.
Yeah, I'm fine with that. I'm talking about the first term.
Because 30 become like this 30x here, because just taking that derivative.
Oh, I see what you did. It's fine.
I just set the incorrect lower bound. I really deeply apologize again because I'm so sorry I make a mistake, but I will try not to make any mistake in the future problem. So are we all good? I promise. No more mistake from now.
All good, no worries.
Because I'm an oligarch right now, so. I feel nervous when people leaving because I'm trying to make sure it did not I'm making this stupid mistake just cause people leaving because I try to do my best. So
Andy, it's fine. I mean, even our professors have made tiny mistakes before when presenting. It happens.
because I'm an oligarch right now, so at number 3 it is this integral. I think it's from Beckel. Like an older exams, we have this integral. So can you just see on my screen, right? So the e to the square root of x, then dx. Okay, so when we see like a radical, they're like x. Then we just try to rationalize the expression, and then we just use integration by parts. So first we just make like a u substitution here. So we let to u equals to the square root of x. Then u squared is x, then dx it is 2u dx 2u du here. So like when we make the u substitution, we change the bound because it's a definite integral. So the lower bound becomes a 0 and upper bound is a 2. So we have is like a 2u du du. Is this correct, right? Because I just want to make sure that I don't make any like super basic from now. So if I make any, so please let me know. So 2 is the constant, and I just pull like 2 in front of integral. And then we do IVP. And because now we use the u again, so we change like another variable. So it's like this equals to u, then d w du, and then dm it is EU, DU, and then M, it is M is EU. If we're calling in the integration by part, we have the two of this thing. It's going to be U, EU, 2, and a 0, the minus 2, make sure it's like a 2 is the whole thing. And then V du, so this time it's going to be EU, du. So now we have is do like 2 times E2. So this is going to be 4 times the E2. And for this, just the EU, and then just the back to it, going to be 2 EU, going to be 2, and then 0, we guess like E2 for E squared minus 2E squared minus 2 plus 2. The final answer it is why are we doing this? Oh, come on. So I'm doing right. Because I'm trying to make sure that I don't make any mistake. So we just like rationalize. Let me do IBP, and that is all for this integral. So are we going to move on to the next question? I don't know why I'm today making so many mistakes today, so I apologize for it. So number 4 is the trig integral. So it's even cosine okay. I think now you can see on like my thing right here. So I think the first thing is do the U substitution because like you want to get rid of this 2x. So just to make this U sub, and you will get 1/2 over cosine of 4U du. I think that now is the thing to use like the double angle identity here. So you can rewrite the thing as 1/2 of cosine squared of U in times cosine squared of U, and then du. And then we just rewrite them as I think it's a half or double angle identity here, and then we're just gonna be 1/2 plus 1 cosine of 2U, and then there's oh wait a minute, I need to take on the white out here, so because my mistake. I apologize for the waiting time. So I'm just guys, I'm so sorry. But I would do my best, just give the most accurate, most right answer as possible. I think for now you just have this because this is just cosine squared of U, and you just expand this, and then just expand this expression, and then do another round of U sub. I think. It's gonna be 1/4 and plus 1.
Andy,
Oh yeah,
quick question. So you know how we have 1/2 plus 1/2 and like squared and all that stuff? Are we not gonna pull out another constant?
yeah, we can, but I already did that way, but the basically is same. We can do the constant a to the 1/4, but yeah, then
Yeah,
that is
that's what I
basically
was
the
referring to.
same.
I mean, it works either way though.
Yeah. Yeah, the basically is same. Jeez. Apologize for the mistake here. I was just not purposefully making a mistake. I would just have 2AB gonna be cosine. Oh, jeez.
Also, do we FOIL for that part?
Yeah, because they're this, because like cosine squared and square it is 4. So we just expand it because this is a plus b squared. So we just expand a bit. Then we can do u substitution. here, 'cause-
Also, the thing is that if you expand this, personally, like what I see is, oh, this is nicer when I expand it because I can split it up into like 3 more different integrals, and sometimes that makes life easier.
Yeah,
No,
this
what I
is-
mean is like for this, when we're expanding it, we don't just apply the exponent, right? We actually multiply the first, or we FOIL it. You know, we do the first and the first on the first one, the last on the first one, the last on the first one, the first on the last one, and then both of the last ones. You multiply those to get each of your terms, right? Okay.
Yeah, so just expand it here. I think for here, you need like another rewrite as like a 1/2 plus 1 over cosine of 2u. So just another round. Yeah, so we just do 1/2 is here. So gonna be 1/4 and plus 1/2 over cosine of 2u, and then plus 1/4, and we have 1/2, then plus another cosine of 2u. Yep. Wait, not sure this should be 204, but it's yeah, but it's that way. So wow. That is and then just a split up integral here. We just do like 1/4 plus 1/2 cosine of 2u and plus 1/8 and plus 1/8 of cosine. What do you guys think here should be 4? So this is on the page 3 on the outline is like the trig integral even cosine. So this is problem 4, and I'm gonna go question 5 after this. Okay, so they're gonna be 2u.
Andy, please pull the paper up again. It's off the screen. Yeah, thank you.
I think now you can do the u substitution again, then just back for integration here. Do you think it is on the red track, right?
Yeah, I would. I mean, yeah, either. I mean, I suppose you can just keep that as one giant interval. It doesn't really matter if you split it up into tiny intervals. As in take each term and just make it its own integral. But either way, you still have to undo u sub.
Yeah. because you need to do two use up here, because it's this, and the one's like this chunk.
And then there's like special identities that we know. I can't remember off the top of my head, but cosine 2u, cosine 2 theta, cosine 2u has a special equivalency thing that I don't know off the top of my head, but it exists.
Yeah, that's like cosine. Yeah, that's like cosine square. So like cosine square, it is 1/2 times like 1 plus cosine of 2x, and for sine squared of x, it is the 1/2 times the 1 minus cosine 2x, I think. And just to do this, so you need to do like another kind of integration here. And just to I think this is the right track. And then plus back to u is like a 2x, then you will get is well, I forgot to do this, like u equals to 2x. And then just to put back in, that is your answer. Oh. So does this make sense to all of you guys? Because I just I don't think I make any mistakes so far. So I feel good.
Yeah. Andy, are we gonna finish on doing the U sub, or are we just gonna leave it as is? I mean, I guess we can leave it as is for now.
Oh wait, what question do you mean?
Oh, I meant the question that we were just working on, because I still saw sine 2u and another sine 2u. And
Let me
I'm
just because
wondering
this is
why
already
it's half
done.
done.
So we just and then we just replace back to the 2x and it become 4x, and that's it.
Okay, thanks, Andy.
Oh. Then number 5 is on my outline. Number 5 is like a trig, another trig integral, but it's like even odd tangent, odd secant. In this case, this is like so what they have is tangent to the tangent power of like tangent power of like 3, and then secant power of 9 x dx. And now you just have the even tangent, odd tangent and odd secant. Then what you can do is like, in this cases, and you have odd tangent and odd secant. Let me try to pull one secant and one tangent out. So it is we'll have the tangent the x, and then we just factor one secant out. Wait, and one tangent. I should do this. Secant to the 8. Secant and tangent of x. In this case, for tangent of square, we already pulled this out. And the one thing to notice that the derivative of secant, it is this. So for tangent square, you can rewrite the mass secant squared of x minus 1, then multiply by secant to the 8x and this, and secant of x and then tangent of x. dx. Now do u substitution. So u is equal to secant of x, and du it is secant tangent dx, and du it is one, du gonna be dx over, so dx gonna be this over, dx gonna be du over this, dude. So we just new integral, and it's gonna be u squared minus 1 times u8 du, because this and this just cancel out. And let me just expand, gonna be u10 minus u8 du. Then we will have to do 1 over 11 u to the 11 minus 1 over 9 to the u to the 9 plus constant of integration. Since this is an indefinite integral, so after the integration, we just replace u here. So the final answer will be 1 over 11 secant to the 11 of x minus 1 over 9 secant over 9 of x plus constant of integration. Does that make sense to you guys? Is there any questions? So we're good.
Makes sense. Thank you.
Welcome. Okay, question number 6 is the trig sub. So just heads up, because like all the trig sub on my outlines, they're all completely squared because I know they are the hardest. So there are multiple of them. And I think, and I hope that helps. Okay, so this integral is x minus 3 over x squared minus 6x dx. Oh yeah, this integral can be done by partial fraction, but also can be done by trig sub. So do you want to know how to do this? So do you want to know how to do this with the trig sub? If yes, I will do it. So this is the very tricky part. So x squared minus 6x, it is going to be x squared minus 6 plus 9 and minus 9. And then it's going to be x minus 3 squared minus 3 squared. So this is x squared minus a squared. So s squared minus a squared the cases. So we sub that x minus 3 equals to 3 secant of theta. And then dx, it is 3 secant tangent of the theta here. And then the new integral, well, x minus 3, wow, it's right there. So you just put them there. Gonna be 3 secant theta. So this is gonna be 9 secant squared minus 1. No, minus 9. And then 3 single and then tangent of. This is 9 tangent of square. This is going to be 3 secant of theta over 9 tangent squared theta over 3 secant of theta tangent of theta. The tangent here is canceled, then like it becomes this. We have a 3 secant squared. Wait, it's 9, right? It's not. I think not. 3 here. And over is 9 tangent of x. Sorry if I make any mistake here. I think now you can make a u substitution. Because if u equals to tangent of a theta, the du it is secant squared of theta, d theta, and then dx is can be canceled and just 9 and 9 just becomes a 1. And then we so just let me know if I make any mistake here, because this question is kind of yeah, because this is a kind of hard one. So just gonna be 1 over u du, and then you're just gonna be like a natural log of u polynomial integration. It's like it's natural log of a tangent theta. Actually here, because this is an indefinite integral, so we try to express the tangent of theta here. So if you draw like a triangle here, so it's going to be decant is going to be like this, so 3 x squared minus 6x. So the tangent of a theta is the radical x squared minus 6 over 3. So does this make sense to you guys?
How'd you get like the values in the triangle? Like the 3x minus 3 and the x squared minus 6x?
Because if x minus 3 equals 3 secant of theta, then x minus 3 over 3 it is secant of theta, and the secant is this and this.
I see. Thank you.
Yeah. So does this question make sense to you guys? Sounds good. Number 7 is another trick sub. I bet this one you will see it's very similar to the one unlike the web assign. It is another trick sub. It's gonna be 2x squared and minus 2 over x squared plus 4x and minus 4 squared dx. Well, it seems kind of dumb use of, but it's no. And you need to do complete the square because x squared plus 4x plus 4 is non-factorable. So x squared plus 4x minus 4, it is x squared plus 4x plus 4 then minus 8. So gonna be x plus 2 squared and then plus the radical a to the square. Because I keep radical 8 instead of 2 radical 2 because it's easier because like I don't want to there are too many numbers there. So does it make sense to you guys? And this is x squared plus x squared plus a squared. So this is x squared plus a squared cases. So we let x plus 2 with the square root of 8 of a tangent of theta. So we let x plus 2 with a square root of 8 tangent of theta. Then dx it is square root of 8 secant square root of a theta d theta. Now we can do this. 2x squared. So x, if x plus 2 is square root of 8 tangent of theta, then x is the x will be a square root of 8 tangent of theta minus 2. Does this make sense to you guys?
Yep.
Yep. Well, this one is theta minus 2. Oh yeah. And square root of minus 2. This is gonna be 8 tangent of square root minus 8. Oh no, 8 tangent of square root then plus 8. Then it's gonna be square root of 8. Secant square of theta. I mean, just rewrite the integral. Well, maybe just don't expand it. Later, I will show why don't expand it. But just leave them there. This is gonna be wait 8 secant of a square theta square root of 8 secant squared theta here. And this canceled. Now we have is this. Wait, I think I have to expand it, I think. Well, oh well, never mind. Well, I promise I will solve this problem. I will solve this problem. Trust me, I can do it. 2 square root of 8 will leave them there. Yes. Well, just over 1. Because like the secant square, it just canceled. Then it's just like this stuff. And the radical 8 is constant. So try to pull them out. Square root of 8, not a square root of 8. Tangent of squared. Minus going to be 4 square root of 8. Tangent of a theta. And then plus 4 theta here. Now we just try to integrate this tangent squared Wait, for tangent square that you might think it is hard to integrate, but here's the trick. So radical 8, they're the same. And you put them as 8 as secant square root of x minus 1 minus 4 square root of 8 tangent of a theta plus 4 theta here. For now, because we know the antiderivative of secant square is just tangent. And the antiderivative of tangent, okay. Sorry, I need to pull up like integral tables here because I some just can't remember what is antiderivative of a tangent. Oh yeah, I remember it. So we expand this whole thing. It's gonna be 8 secant squared of theta minus 8 and plus 4 square root of 8 tangent of theta plus 4 the theta. So I'm doing right here. Is there any mistake? If there any, please let me know. So we just I try to multiply square root of 8 to everything. So this is going to be 8 square root of 8 tangent of theta minus 8 radical 8 of theta plus 32. So the natural log of, so antiderivative of tangent is natural log of secant of theta, then plus 4 radical of 8 theta plus constant of integration. Now we have this giant ass antiderivative. They're only in terms of theta, but one in terms of x. Now what we can do is draw the triangle, because we know if x plus 2 it is square root of 8 tangent of theta, then it's like this. So and then this is gonna be tangent of theta. It is x plus 2 over square root of 8. So gonna be x plus 2 square root of 8. Then this is gonna be x squared plus 4x minus 4. Then tangent of theta, and for theta you just do arctangent of x plus 2 then radical of 8. That is the angle. So we jump back from there, and we have well, they're the same actually, because square root of 8 is 2 square root of 2. The x square root of 8 is just 16 square root of 2. Does this make sense to you guys? So tangent of theta, it is x. It is x plus 2 over square root of 8 minus 8 square root of 8 arctangent of x plus 2 square root of 8 plus 32 natural log of secant just of this. So it's gonna be 32 natural log of Wow. This is so. Plus 4 square root of 8 of arctangent of x plus 2 over square root of 8 Pascal's of integration. Oh wow. Is there any question for me? Because I know this one is hard. So are we all good about this question?
Yep, thank you.
We move on question number 8. Another completing a square. Problem is, this is the last completing square that I will go over today. So it's almost end of the hell. We're almost there. It's number 8. So we have still this integral is gonna be 4x minus 3 under the radical of 3 plus 2x minus x squared then dx. Well, if you do use up, that doesn't work, then just completing a square again. So after question number 8, that I will maybe pause a while. So if any of you guys have any question, feel free to ask me. So we write them as this: minus x squared minus 2x minus 3. So actually it is x squared minus 2x plus 1. It is so for this is a square, and then how we now we have this is a minus 1. How we get 3? So it's plus 4, and then we move 4 to this side. We get is x squared minus 2x and plus 1. And what we will get is 4 minus x minus 1 to the squared. This is a squared minus x squared. So we let x minus 1 equals to 2 sine of square. 2 sine of theta. So is there any questions for me? So I'm doing all good. I have like 4. Oh my. Apologize for those mistakes, because at some point write minus as a plus, at some point write minus. Yeah, but I would just change it immediately. Then dx it is 2 cosine theta d theta here. Now let's rewrite the integral. If x minus 1 it is a 2 sine of x, 2 sine of theta, and x is 2 sines of theta minus 1. Let's rewrite this whole bunch of integral here. Sine of theta minus 1 minus 3. Yeah, that's gonna be 4 sine of square minus 4 minus 4 sine of squared. So the numerator so it's like this. We have this is 2 cosine of theta. Now we change this is cosine square turns to cosine of an x or or is it whatever it is? I'm sorry if I just like skip too many steps, so let me know if you have any confusion, okay? For cosine squared of x, cosine squared of theta becomes 2 cosine of theta, you have cosine of theta here. This dude canceled. As it's just canceled away, we have this. That is so much more straightforward, right? Gonna be 8 system theta minus 4 3 7. We have this. So, and then we just do antiderivative. The antiderivative sign is negative cosine. It'll be like a negative 8 cosine of it. The theta minus 7 theta plus constant of integration. Now let's write what is the cosine of theta. Because if x minus 1, it is 2 and of theta. Now x minus 1 over 2, it is sine of theta. So are we all good? And then we just show that what are those side in a triangle here. It's gonna be x minus 1 and then 2. And then this is the bottom. It's gonna be 3 plus 2x minus x squared. And then cosine of x is this over this. And then it's gonna be negative 8. Wow. Minus 7 is like this, and just the arctangent. So this is gonna be inverse tangent of and then plus 7 of inverse tangent of x minus 1. And then gonna be 3 plus 2x minus x squared plus constant integration. Those can be done like a negative 4, and that's remaining the same. Does this make sense to you guys? Is there any questions? So we are finished all the tricks of questions. Now it's time for the partial fractions. So hard things are going away. Question number 9 is this partial fractions. Just says 2 and a 1. I'll just copy this 4 and a 2. It's gonna be 9x squared minus 21x over x4 plus x2 x4 plus x2 dx. So if the bottom have a higher power than the top, then this function it is reduced. When the function it is reduced, we do partial fraction decomposition. So we do PFD. And the factor the denominator So with 9x to the squared minus 21x. So it is over x squared plus 1. This is repeat the linear and some irreducible quadratic formula here. So we have going to be a over x plus b over x squared plus 6 plus d over x squared plus 1. And then we just set 9x squared minus 21x minus 0 here. So like that's just a placeholder when we just define what this ABCD is. That makes the life easier. We have multiplied by a by x and x squared plus 1, then plus b times x squared plus 1, then plus cx plus d, and x is squared. Yeah. Then just solve a linear like equation. It's gonna be ax to the cubic. So gonna be a plus cx to the cubic. We have ax, and then plus bx to the squared, and plus b plus d x to the squared. We have ax. We have 1b. So is there anything I'm missing, or I'm all good? There's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I'm all good. Is there cubic? So the tricks. So now it's also just solve this. So we have a plus c is a 0, and then b plus d, it is 9, and then a, it is negative 21. B it is as 0 here. Then we can solve this. Then we get C it is 21. D is 9. So A is negative 21. B is 0. C is 21. D is 9. So so is there any problem is there any error you spotted? So please let me know. Okay. Hey, is there any questions? Because I had to make sure that I do the PFD right. Because if PFD is wrong, the entire thing is wrong. I'm gonna hit this 21 over x, and plus if the b is a numerator is 0, the entire thing is a 0. 21 x plus 9 x or plus 1. For this, just split it up. Then you would know, then do a U substitution. So this is gonna be like a negative 21 natural log of 2. So says any derivative 1 over x, it is the natural log of x. If I more like a negative 21 out of a constant, then just multiply back. That's why it's going to be negative 21 natural log of 2 of this one. Now let's do this mess. How can it be 21x over x squared plus 1 dx? Oh, this is the arctangent of x. So what if we just to do like it can be 9 arctangent of 2, then minus 9 arctangent of 1. And then we do u separate for this. If you like to u equals to x squared plus 1, then du it is the 2x dx. Then this is going to be canceled. The 21 is constant. Then for this become as arctangent over 1 is a pi over 4. Is going to be not pi over 4. So we have well, for this, just leave it as this because arctangent of 2 doesn't have an exact form, so just leave it here. So we have this going to be changing to 5 and 2. 21 over 2 is a constant. That's going to be 1 over u du, and then plus 9 arctangent of 2 minus 9 pi over 4. Hello. And then just to do like a natural log again, gonna be the negative 21 natural log of 2 plus 21 over 2, not 5. And it's gonna be natural log of 5 and minus 21 over 2 natural log of 2, then plus 9 arctangent of x of 2, then 9 pi over 4. And this just gonna be I'm just gonna I'm gonna leave it to this. Does this make sense to you guys? Any question for me? So are we all good?
Yep, thank you.
I'm changing a pen because my this pen isn't run down the ink right now. So okay. Let's do number 10. Number 10 will be the question that I bet you might hate to be on the exam because you even know how hard it is. So number 10 is a partial fraction, long division, and volume. Are you guys ready for that? So gonna be like a volume, PFD. So PFD, it is, I just call them a partial fraction decomposition. That's why I call them PFD. And for each equilibrium part, I call them IBP. For tricks, coming to I call them CTS. This is how I just abbreviate them. Okay, now let's do if this is like a region bound by this curve, y equals 2 x cubic then plus 4 over x minus 2, then x plus 2, and x 3, x equal to 4, y equals to 0. So first we can do just to sketch the region. So we have so perhaps this is the whole thing. We have from 3 and from 4, and then we just because the rotating the region by the y-axis. Okay, so add on. So for question number 10, then it should be find the volume of solid, rotating the region by the y-axis. This question is like a missing things, so I apologize for it. Because and this volume of shell rotating by the y-axis. So the shell method, it is 2 pi x f of x dx is 2 pi x in the region. So when we just gonna set up the volume, so the volume is gonna be from 4/3. This is the lower bound, upper bound. Here's region. Gonna be 2 pi x. This is like this, gonna be x minus 2, x2 plus 2, then dx. Because now if we multiply this, this would be in the power of 4. This denominator have a power of 3, 4 greater than 3, so we need to do long division. Okay, wow. I bet you hate to do long division, right? But now you just have this question. I'm gonna solve it for you. Trust me, I can do it. So let's show you the magic here. Make sure just expand it at the bottom. Otherwise, you can't do like a long division. Well, this mess. Okay, let's do polynomial non-divisions. Gonna be x to the 4 plus 0x to the cubic plus 0x to the squared plus 4x plus 0 here. And then we have it gonna be x to the cubic minus 2x squared plus 2x and minus 4. First, we need to multiply the x. We multiply by x everything, so x is x to the 4th. Then 2x squared are gonna be minus 2x to the cubic, and then gonna negative 2x to the squared minus 4x. Then what you left, it is 0 plus 2x to the cubic plus 2x is squared. Wait, I think this minus 4x it is. And do you think I do like another round of partial fractions? So if you just collect into 2 here is 2x to the squared. 2x to the squared minus 2x to the squared plus 4x minus 8. All right. So is my partial fractional division right or not? Because I try to make sure that that don't make any like we're silly mistake here. So it's a 4x minus 8. Wow. Then when we do the integral, just follow them again. To the cubic, we have x plus 2 and plus of 4x minus 8 of this messy integral. Then now do partial fraction of this mess. Then that is the whole thing. So does this make sense to you? Or do you want me to solve the problem? Or do you want to jump to the next, or do you want me to jump to the next question? So did you multiply them by 2 correctly? Hi, Tara, can I do the which is the, so which part is like the 2 thing here? 4x to the square? Here, right? Oh, shoot. Correct. Thank you for catching that. Guys, I apologize for making mistakes through this long ass integral. So okay, so we just do the minus. We get this a minus 4x to this square, the plus 4x, just minus 4x to square. Is this correct for you? Oh yeah, 4x. Thank you for catching that. And then add power 3, then do partial fractions. Yes. So do you want me to solve this integral or just leave it as it is? So do you want me to solve the integral? Yeah, yes. It's gonna be it's gonna be a negative 4x to the cubic minus 4x to the squared plus 4x and minus 8. This x squared plus 2, right? Yes. Dx. And now do partial fractions. 2x squared minus 4x plus 4. Okay, I will see where I'm messing up. Oh, never mind. So if you guys want me to redo this long division, I can, but not now, okay? Because that just I need to restart like the problem. Okay, let's do PFD. Stop solving the integral. Oh, geez. So 4x to the cubic plus 4x and minus 8. I have this mess, x minus 2, x squared plus 2 is equal to This is irreducible quadratic. So I have it's going to be a over x minus 2, then plus bx plus c over x squared plus 2. Then just multiply this whole thing. Yep. A multiplied by this is gonna be ax squared plus 2 and plus bx plus c over x minus 2. Now we just expand the whole thing, so we get ax negative 4x squared minus oh yeah. Wait, Tara, I think your make all the correct because like there's no term x cubic here. Or maybe, well, over there, man. Okay, so I'm just gonna. Hey guys, I really apologize for it because well, I will just continue to solve this integral. Okay. I apologize for too many mistakes tonight. Not gonna be plus bx plus 2bx plus minus cx. Then we have gonna be minus 2c plus 2a. The a plus b is gonna be like a negative 4. Well, I think, well, I will check this question later. If I solve it incorrect, I will redo this problem and send this to the server. And feel free to catch my mistake tonight, but I will try not to make any mistake, okay? So there's going to be my c. It's going to be 4. 2a minus 2c, it is 8. Now we try to solve for this linear, solve for this. Now we time this 1, 2, 3. Because this one is not easy as the last one, so I'm just gonna. So if we multiply 1 by 2, so we get gonna be 2a plus 2b gonna be negative 8. And 2b minus c is gonna be 4. If we minus this, it's gonna be oh wait, no. Why am I doing this? Okay, I can solve it. Trust me, I can solve this. I can solve the system of the equation. Why am I making such like a dumb mistake here? Okay, then Well, guys, I'm just gonna leave it as this. So later, if I just gonna, so I'm just leave this as this because here's the hint. And for this, do a U substitution. For this, do another U sub. Then you are done with this integral. Okay. Are we? So do you think it's good to move on to the next problem, or do you want to me just to do something else? Are you good? It sounds you're all good, right? Okay. Now let's do some improper integrals. I know this part, I know you may not like this part, but I will do this problem for you, so no worries. You will be good. Question number 11. So this is the type 1. We have upper bounded as infinity and the lower bounded as let's do here. I think it's like I think question number 11 lower bound it should be 4, not a 2. I just type it wrong. Okay, here guys, I deeply apologize again that too many mistakes. Actually, on the final reviews, I will make sure I have 0 mistake for you guys. I promise for this. If for the final exam review, I promise there's 0 mistake. Trust me. Guys, I hope you guys still just trust me because I did not purposefully make those mistakes. So this is a type 1 integral. Type 1 improper. So upper bounded is infinity, lower bounded is a constant. So now what we should what should we do it is we just find antiderivative, then we use like a limit. If the limit exists, then the integral converge, otherwise it diverges. So for this integral, let's do a U substitution. Well, don't expand this. We have set a U equals to x minus 2. X is U plus 2. So we have it's going to be 6 and U plus 2 over U to the cubic and du. And then we expand that's gonna be 6u gonna be 6 over u squared plus 12 over u to the negative until like a -3. I would write them in like a negative exponent form, so it makes me easier just to find what its antiderivative is. So some antiderivative of 6 to the negative 2 plus 12 to the negative 3 and then du. This is going to be 1 over negative 2, going to be negative 1, going to be negative 6 to the negative 1 plus into 12 going to be negative 6 to the 2 plus kind of integration. Okay, now we have this mass, and we sorry guys, yeah, I'm just a bit tired, so as upper bound we just set to like t equals to infinity here, and then solve and define antiderivative. So like a limit of t to the infinity. Just yeah, right. Integrate the function. Why I'm integrating it? Oh. Let me just gonna be t and the 4. If we could use lower bound should be 2, not 4. If t is like infinity, then it's like a 0 and yes, a 0 and a 0 here, and the minus gonna be negative 3 minus 3 over 2. So it's gonna be 9 over 2. So the improper integral converge because the limit exists and is a number. Does this make sense to you guys? Feel free to ask me questions. So we all good?
Andy,
Yeah.
just wondering, is it possible to do this example, but with the, what is it called? Comparison test?
Yeah, there will be one on the comparison test. So I'm gonna do one for type 1 and one for type 2 and then one for comparison test. Does this answer your question, Lillian?
Yeah, that does.
So this is type 1. We have infinity bound. For type 2, gonna be discontinuity inbound. Question number 12, it is another long division. So do you want to skip it or do you want to do this? Because I forgot there's like another partial fractions. Well, I'll just skip it first. Let's do some improper integrals. So 12. Question number 12 here. So the type 2 is just like a discontinuity between the bound. So this question that is 3 and a 0, 2x squared plus 1 over x minus 3 to the squared dx. To evaluate the integral, I think, well, I can just do a u substitution in this question because I don't want to do a partial fractional division. So here's the trick. If we u gonna be x minus 3 du equal to dx. The x the u minus 3 is x. Okay. Guys, I would do all, so I would do 13 to 14. And I think
Shouldn't x be u plus x, or sorry, x be u plus 3?
yeah, because we just integrate the question because because how I do improper integrals, like I do the integration first, then we do like a limit and then evaluate the limit, see if the limit exists or not.
Wait, and that's for the substitution for u equals x minus 3, where it became x. Is that right?
Because like the numerator is 2x squared plus 1, and we want to write x in terms of u after the u substitution because we can't have two variables in this integral.
Yeah. So then when you made u, or sorry, when you made x from the u value, shouldn't it be u plus 3 instead of u minus 3?
Yes. Thank you for catching that because
Of course, no worries.
I'm a bit of a tired tonight, so I'm constantly making a mistake.
Of course, you just did like 11 problems in a row. It's very tiring.
Yeah, and you did that really fast compared to how fast I would have to do them.
Like on a test or something, I would not be able to do it that fast. Thank
and
you.
And I was doing something like a math lab. That was just computer science like a beat him up today.
Yeah, we're on the 6th assessment, Nathan, which has to do with Mad Libs. It's the thing that I was exhausted about on Friday.
Tough. Okay.
Yeah, that's why I'm feeling a mystic today because because I'm tired. The expand this thing. Oh, change the bound. Oh,
Although, do you really have to change the bounds? There are times where I'm like, I don't want to change the bounds, and then just leave off the bounds in general, and then put the bounds back after I, undo the U sub.
I did the use sub, but then I need to change it.
So unless it's in terms of x, you do need to change the boundaries. So that's what he's doing. He's just leaving the boundaries in so that he can, yeah.
Actually, for now, I just write out antiderivative and just do limit, but don't just evaluate because this just to do like a discontinuity here. So, but I'm just write out like a process when do the integration. So it is. Two gonna be 12.
Quick question, Andy.
Yeah.
So do we just, okay, so usually when I see these things and it's, what do you call them? Improper integrals or something like that. Usually you throw a limit in front to like get rid of the can't plug it in number, like as in can't plug in 0. Do we just not do that here? I'm a bit confused.
Okay. Yes, I was just gonna explain that how I'm gonna do this because like I can either just evaluate the integral now and then do the limit, or I could just evaluate the limit. Well, anyway, you have to do the integration. So
Okay, thanks, Andy. Although I suppose you can just put the limit on later.
yeah, so it is just the time. So yeah, but yes, you have to do the integration. Yeah. No. Oh wait, 19. Yeah, yes. Well, then just ignore this because if only find antiderivative, then we do the limit. So this is just like if we just do like a use up, then yeah. Plus 12 natural log of u. It's gonna be like could be 19 u to the -2 power. It could be like a negative. It could be negative 19 to u over -1. Yes. Okay, so we're gonna leave this, and now we're gonna do the improper integral. Because it's like the discontinuity is on upper bound. So we just do like a limit of person going to be t approaches straight from left side to make sure it is in the bound. And we have this giant as antiderivative. So if it's like a -3, or it can be like 6. And now we just do like this. It's like 12 is for the log is like we just process rate and just decreasing, and if like the well, the thing here, if you plug like a 0 here and it's like undefined, and just it goes to infinity here. So this integral diverges. So why it diverges? Because the limit doesn't exist. Because we just look approach like the left side, so it's being so getting close goal to like 3, and then we just Yeah, and it's divergent for like and for like the denominator cannot be a 0. Does this make sense?
So
Or
what's the difference between diverging and converging?
so the converging it is when you evaluate like the limit. So like this case is this is kind of like a 0, but it's like actual number. So it's like so if the limit is exists like this is a number, then it's converged. Well, for this is it might be like infinity, or does not exist.
So just to clarify, finite value, as in like something that is not infinity, means that the thing is going to converge. But if you diverge, it means that you have negative infinity or positive infinity, or just doesn't exist. That's what's considered diverges, right?
And that's
Yes.
within the range. Okay,
Okay, so we are heading to our I think it's gonna be like I would do last one, but it's not question 14 because like 14 it is not yeah, 14 is a comparison test. Or we can do like a next, or just like one that I found it is kind of a tough. So do you want to do that one or do number 14? Because I found this.
Please go over the convergence test. I mean, comparison test. That thing is kind of causing trouble.
Oh, question number 3 from page 19 of the, I think of the exam that I. Okay, so I will go over number 14. This is the last one on my review document. So I will go to number 14. So this is the last question that I'm going to go over today before the Q&A. So after this question, feel free to ask me any questions that, or I can redo that integral. Okay, so this number 14. 2 and infinity. Of actually the 4th over the 5 minus 2 the dx. Oh wait, I'm checking a message on Discord. So just wait a moment. I apologize for it, maybe because I needed like a short break from like 12 straight questions. So I'll be back in very shortly. Okay, I am back. Okay, so what do you mean by comparison test? We have this nasty integral, right? And we just because x minus 2, if we put them on the calculator, it doesn't make any differences, right? So x minus 2, we plug in x to the 1. So if x to the 1 minus 5, and it's gonna be negative 1. If you plug in x to the 10 minus 5, it is So it just to make the whole thing smaller and smaller, just not like a huge swing. So we can just write the mass. So they're very similar to this. If you just do like infinity and a 2, x4 over x5 dx, so just the 1 over x. Just the 1 over x dx. So this is what we have now. So we can just and now we just try to find it's like that whether this integral diverge or not. We just evaluated this integral, and then we just guess is this diverge or converge. So there's like the thing about this type of thing. If the upper bound is say infinity and the bottom is a constant, the 1 over x to the n is a power. So if n is smaller than 1 or equal to 1, then it integral diverges. Otherwise, if n is larger than 1, it converges. So because adding anything on the bottom does not change the output of a function like huge. So we just because it just make very small changes on the output. So those two are basically they're the same thing, but just like some different output. So we just evaluate this and we turn to like x1 over x to the 1. Since this is 1 equals to 1, this integral is divergent integral. Does this make sense to you guys?
Yeah, that makes sense.
And even if you make a U substitution, you're still going to get a power of 1 or like a natural log of 1 here. So it is still going to be diverge. So even if you make a U substitution, it's going to be 1 over 5 over U, and U is the same as X with a power of 1. So it just diverge. Does this make sense to you? Because even if you U sub, it's still going to get very the same thing. Does that make sense to you guys? So I think I covered all the question that I put on the my study guide, because the after 14 it is kind of the practice exam from other instructors. So just look them for like to see that what kind of question they usually put on the midterm. So now is the time that you ask me a question that I can answer for it. Any questions for me?
Yeah, I have specific questions I want to go over.
Yeah, now you can share your screen.
Also, do you mind like turning off the recording at this point?
Also, thank you for everyone coming, because I'm sorry that I make any mistake tonight, because my bring it is not 100% of not operating 100% capacity. So, it is well, but I can still help you. So
Okay, Andy, one people are gone now also too. So I did these problems and the answer key disagrees with both of what I did for multiple of these problems, but I don't understand why it's wrong.
well, in this case, you need to factor the cosine of x out. Yeah.
But yeah, these are the things that I did right here.
So what is the answer key?
What? Oh, also, Andy, you're still recording, I think.
So should I stop recording?
Yeah.